All right, in the last video, we derived the 2 by 2 determinant formula using the area properties. Let's kick it up a dimension. I claim we can get the 3 by 3 determinant from some volume properties. So, all right, let's do this. The general 3 by 3 matrix, let me just go right ahead and just do A, B, C, D, E, F, G, H, I. All right. And let's think about, make that look a little more like a G. So the determinant of A is, remember I said we sort of use these absolute value signs to represent the determinant. So whereas when it's in square brackets, it's a matrix. When it's in absolute value signs, it represents a number. And if you remember some of the volume properties, let's think about some of the volume properties we need. So one of them was that, one of the big ones is that if we had something like the volume formed by V1 plus V2, let's just say U and W, so formed by those three vectors, the parallelepiped made by those three vectors forms a volume, and if we take that volume, then that's the same, we can actually break it up over that plus sign and say it's the volume formed by V1 U and W plus the volume formed by V2 U and W. Okay, so that's the first thing, is we can break stuff up over, if we have a plus sign, we can actually break the volume up over that. And that could have been done in the second or third variable too. It doesn't have to be just in the first. Another nice thing is that if any of the columns are 0, right? For example, if I had something like that, then that volume would just be 0 because there's, oops, that's supposed to be the third vector is not supposed to be the same thing as the first vector. If any of the columns is 0, then the volume is 0 because there's not really a parallelepiped anymore. It's sort of degenerate. And last big thing is that if we switch the order, if we swap any two of these, say I swap the second and third, order really matters here. It's the volume. So if I take the volume formed by V1, V2, and V3, turns out to be sort of the opposite of the volume formed by V1, V3, and V2. It's sort of, there's a right-hand rule thing here, and if you switch the order, you actually pick up a minus sign. And this is true for any swap. I could swap the first and second column. I could swap the first and third column. Also, these things are true for rows. Remember, I could swap the first and second row or the first and third row. And the other two properties above are also true for rows. Okay, so I am going to use this first property first. I'm gonna actually think of the first row. Right, let's do the first column. So when I think of the first column, which is ADG, and I'm going to write that as, this is very similar to what we did in the 2 by 2 case, A00 plus 0D0 plus 00G. And okay, this is going to start to get kind of ugly, but it's going to be a little ugly at first, but it'll simplify drastically, which is going to be the point of everything. So let me write the general 3 by 3 determinant again. And if we break it up, I claim that the volume breaks up, right? So like we said, the volume breaks up over plus signs, so the determinant also will. So I could basically write the same second and third column, right? Just like, and then, well, just like in the property above, we had the same, U and W were kind of, UW were in all three of these. So those aren't changing. That's like the second and third column aren't changing, but I'm breaking up the first column over the plus sign. And so, oh geez, what just happened? Sorry, let me try that again. That was strange. Sorry about that. Okay. So I'm just breaking up the first column over the plus sign. Just trying to copy this without messing up. And the same thing, 0, 0, G, BEH, CFI. Really should do alphabetical order down the columns instead of in the rows, but it's kind of typical. Okay, so that is fine. We've broken up our determinant into 3 separate determinants with some zeros. But here's the thing that's cool. I want to now take, say, let's just take the first one. And I want to do the same thing. I'm going to break it up into 3 pieces, except it's going to be along the first row. So I'm going to think of A00, I'm going to write it as a row, or ABC, sorry, as a row vector. I'm going to think of it as A00 plus B. I don't really usually write vectors as row vectors so much, but I'm just trying to illustrate this. So I'm going to break it up. I said this same property works for rows as it does for columns. So I'm going to break this up. And so this whole guy equals, go back to the white, it's a little bit easier to look at. Okay, now we're going to get zeros in the first row, E, F, H, I. I'm just doing this first term above. Oh, I made a typo here. This is not B and 0. I swapped the B and 0. Sorry about that. Let me just, I didn't like that, so it's clear I messed up before. So 0B0, 0EF, 0HI, and 0C is the first row, 0EF, 0HI. Okay, so what does this mean now? This just looks horrible and more horrible. So I'm now taking this 3 by 3 original determinant and broken it up in all these pieces. But notice 0 column, 0 column. So these are both 0. And so in fact, this thing that looks kind of ugly is actually equal to this thing, which is a little bit nicer, right? And I claim if you do the same thing with the second term, let me just say, if we did the same thing with this term, okay, so I'm gonna say down here, but I'm gonna do on the second row now. So DEF, I can think of that as D00 plus 0E0 plus 00F. And I claim that something very similar will happen. You can do it out if you'd like. But these two, when we break it up, will both give us the first column will be a 0 column. So those will go away. So what I'm claiming, I guess what I'm claiming is that, I'm just going to copy the thing I boxed in yellow up at the top here. So I'm claiming that if I take 0, okay, 0D, 0, B, C, E, F, H, I, that's actually going to equal the same thing as 0D, 0, BC, 0, 0 in the second row, HI. And similarly, if we take, trying to find more colors. If we take this third term, and we break up over the third row, then we can just make that row G00, 0. So what I'm claiming is that, sorry, it's hard to keep everything on the screen, but let me try to do it. 0, 0, G, B, E, H, C, F, I equals 0, 0, G. First row is BC, second row is EF, third row is 0, 0, like that, okay? So this is kind of a mess. You can sort of, if you need to pause and trace things through, I'm just sort of saying really that if in some ways what we're saying is like here in the bottom left of the screen, I can get rid of the E and F and just make them zeros. Bottom right of the screen, I can get rid of the H and I and just make them zeros, right? And that I'm not changing the volume. Okay, so now I'm gonna rewrite that just because it's worth being sort of just writing out everything we can. So we've taken A, B, C, D, E, F, G, H, I, the general 3x3 matrix, determinant, and I've written it as a sum of 3 determinants. But they're kind of nice. There's like zeros. There's some structure here, right? It's almost like the structure in this one is kind of like there's A, and then there's this 2x2, and that's going to be important in a minute. And then we did the same thing with the second piece, 0 BC, D 0 0, 0 HI. Another way to think of this, maybe a slightly interesting way to think of this, is that we now had, for example, this A on the top left of this first one, it's the only non-zero entry in the first row in the first column. Now the D in this second one is the only non-zero entry in the first column in the second row. And if I write the third one, so we have the G is the only non-zero entry in the first column in the third row. Okay, and so then there's something similar here. So I forgot to make this. There's some kind of structure here where I have G by itself and the 2x2 there. There's even something similar where it's like this kind of fits together. It's almost like I want the BC. It's almost like I want it to wrap around like Pac-Man and the BC to be there. Okay, so I've reduced it to this, but the question is now, like, what can I do with this? I claim there's something nice, and this is where you need to go back to some geometry. But I'm gonna think about this. Think about this determinant, this first term that I just put the question mark underneath. I could actually really draw that. If I wanted to draw a three-dimensional space, right? So my typical 3D axes, X coming out of the page, Y and Z. Notice that A00 kind of lies on the X-axis here, right? But 0EH and 0FI live in the YZ plane. That's 0EH, and that's 0FI. They really live in the YZ plane. And I want the volume of the solid formed by these things. The volume of the solid formed by these. So it's like, let me just try to see if I can make this kind of, it's going to be a little bit hard to draw, but notice what it is. So like, here's the solid, here's the parallelepiped formed by these. So then there's sort of like a copy of that coming out of the tip of the orange vector. And then I can connect them like that, right? That's the parallelepiped formed by them. And that's what this, let me copy this expression. That's what this thing we've written down, A00, 0 EH, 0 Fi is the volume of that parallelepiped. But because A00 is perpendicular to the YZ plane, it's also clearly base times height. It's clearly A times, it's even too big. I want this to be the 2 by 2, EFHI. That's kind of amazing, right? It's actually, this actually simplifies quite a bit. And we've reduced it in some sense from a 3 by 3 to a 2 by 2. Okay. So that's kind of amazing. We can actually sort of stick this in here and replace that with that. Now I want to do something similar with the second and the third term, but I do need to do a little bit of switching of rows and columns because I want the non-zero entry in the top left down here, and I want the rest of these to be, I want zeros, the rest of the first row and the rest of the first column, and then be left with that, right? So now I can do some row switching. So let's take the second term. Let's take this guy, go down below, and think about what we can do with that. So let me copy that down. I know this gets kind of crazy. Hopefully you're getting this all copied into your notes. I think this was BC00 and HI. And let's actually swap the first and second row because that'll put the D in the top left. And the big thing about that is that we pick up a minus sign. It's going to be really important when we have this general expansion by minors formula, it's called. And so I picked up a minus sign, but this looks exactly like what's just above it. So we can actually rewrite this as minus D times this 2 by 2 determinant, BCHI. So that's awesome, has a minus sign. And similarly, the third term, let me give these names. Let's call this like 1, 2, and 3. So this is the determinant of A equals 1 plus 2 plus 3 in these sort of numbers, right? So this is 1 down here. This is 2. And what about 3? So 3, let me copy 3. 0, 0, G, and then BC, where are these letters? EF, 0, 0. It's hard to keep track of all the letters. Okay, now I need to swap again, but you know, I want BC in front of EF. So what I'm actually going to do is I'm going to swap once and then I'm going to swap twice. So I'm going to move the third row all the way up to the first row and slide the first and second row down a row, right? So that's going to be G00 0 on top, 0 BC, 0 EF. And actually, because there's two swaps, so this is like a minus from this swap, and this is a minus from that swap. So we actually get a plus. 2 minuses is a plus. So we swap twice. So it's actually the same. It's not, doesn't pick up a minus sign. And yet again, we can use the same idea that this is G times the 2 by 2 determinant, BCEF. And that is part 3. And so to sum up everything, we can now write down what's called the expansion by minor. This is expansion along the first column, I guess. So to sum up, barely written any words here, which is always bad. Here's this A, B, C, D, E, F is this general 3 by 3 matrix. My F's keep not looking like F's. Try that again. So it's kind of crazy, but we get this formula, A times the 2 by 2 determinant EFHI. And we just notice that this kind of is like this and these guys. Actually, let me make that, I want to make that not too obtrusive. So it's like that and these gives us this first term. Maybe I'll put a little yellow bracket around that. That's where that came from. Then we get this minus, which is always a bit, throws people off when they see the formula, but you can see it comes from the one row swap. We picked up the minus from the one row swap right here, led to this minus. So we get minus D times the 2x2 determinant BCHI. And again, one way people think about this is they think about, okay, well, D, you sort of think about D sitting right here, and you think about sort of deleting everything else in that row and column, and you're left with BCHI. So I'll put a purple thing around that. And then the last term is the third term up here, the we need to make the pen bigger, plus G times BCEF. And again, okay, the original 3x3 determinant starting to look kind of busy, but that's like this G right here, delete everything in the first column of the third row, and then you're left with this BCEF. And that gives us that term right there. And this is called, there's two different names for this. You can either call it the cofactor expansion or expansion by minors. Let me just write those both. Sometimes the little submatrices are called minors. If you have a matrix, like any submatrix you make, it's called a minor of that matrix. So that's where the expansion by minors comes from. Or in the cofactor, sometimes also like A's, like the cofactor of A is that 2x2 determinant EFHI. And so that's sometimes called a cofactor. It's just different terminology, doesn't really matter. I think the book calls it cofactor. Yeah, you could keep expanding this out and get the full formula, but it's not terribly illuminating. I mean, you could, you could write out this is A times EI minus FH and so on. And then you could distribute in and you get these 6 terms all added up, and it just looks like kind of a mess. But at least this one that we wrote has this expansion by minors has some structure. So that is the general 3x3. It's kind of amazing. It's kind of nice. But it all follows from these volume properties. So there's something I really like about this approach. And then the next video, I'll talk about the general expansion by minors and do an example just to show you. Okay.